this is lesson 7.2 using horizontal slicing. I'm going to show number 4 on page 380. And we're going to slice it horizontally, which means we're going to draw a rectangle so that the longer dimension is horizontal. Something like this. So then our skinny dimension of that rectangle is vertical, runs up and down, so it's a change in y. So this distance right here would be dy. To get the distance between, or the distance from here to here, we need to take our right curve minus our left curve. So we're going to take, and we want to put, because our short distance is in terms of y, we want to put everything in terms of y, so our equations have to be in terms of y. In other words, they have to be solved for x, which they are. So you're going to take 12y squared minus 12y cubed minus our left curve, which is 2y squared minus 2y. That will give us this longer dimension on a rectangle. So I'm going to set up the integral over here. To get the area, integral, remember, is going to add up all the rectangles that would fit inside of here. So we're going to do left curve minus right curve. So 12y squared minus 12y cubed minus 2y squared minus 2y. That's the longer dimension on our rectangle. Let's multiply that by our shorter dimension, which is dy. So if we have the two dimensions multiplied together, that gives us the area of the rectangle. Now we need to realize that we're going to be finding the area of lots and lots of rectangles that would be very, very thin, infinitely thin, much thinner than what I'm showing up here, to fill out this entire space in here. And we're going to be slicing this rectangle from, it looks like we're going to start at 0, a y-coordinate of 0, and we'll be stopping at a y-coordinate of, well, we're not sure. So we might have to use our calculator to find that bound b. So we would just, and actually we could do it without the calculator too. Let's go ahead and try to solve without the calculator, see if we can get that to work out. Basically, these are both equal to x. So we can substitute 2y squared minus 2y in for x right here. So it would give us 2y squared minus 2y in place of that x equals 12y squared minus 12y cubed. Maybe subtract 2y squared off both sides and add 2y to both sides. It's going to give us 0 on the left equals 10y squared minus 12y cubed plus 2y. And actually, let's rearrange those terms from highest to lowest. Let's start with the minus 12y cubed minus 10y squared when you combine these. Excuse me, plus 10y squared, then plus the 2y right there. All right, next, let's try to solve this. Let's factor out negative 2y out of all three of these. I want to get rid of that negative in the front. That's the reason I'm factoring in negative. So to take out negative 2y, that leaves you with 6y squared here, minus 5y here, minus 1 here. And let's bring this up where you can see a little bit better. 0 equals negative 2y. Let's factor 6y squared. Let's try negative, let's do 6y times 1y. Let's try that. And for negative 1, let's use negative 1 here, positive 1 here. Let's see. 6y times y is 6y squared. Multiply these, you get negative 6y plus 1y would be negative 5y. And then 1 times negative 1 is negative 1. So this is the correct factorization. So it looks to me like there's 3 y coordinates where the y value is going to come out to 0. One of them would be at 0, right? If this part, if y was equal to 0, then this whole thing would come out to 0. And we see that intersection point right here. That's our lower bound. Our next one would be at whatever makes 6y plus 1 equals 0. I subtract 1 from both sides, I get 6y equals negative 1. Divided by 6 on both sides, y would equal negative 1/6, which would be somewhere below the x-axis, so that's not the one we're looking for. And then right here, the number that would make this coordinate, or this part come out to 0, this factor come out to 0 would be y equal 1, which would make the whole thing come out to 0. That's our upper bound, right here at 1. So, our boundaries go from 0 to 1. We start to slice at our lower number, and we stop at our higher number. Now let's go ahead and simplify. Change this subtraction to plus, change the signs in the second parenthesis, and try to make that a little bit simpler before we do the integral. So I'm going to have 12y squared plus negative 2y squared, that's 10y squared, minus 12y cubed, plus 2y. Remember that when we do the antiderivative, we make the exponent 1 bigger, so this is going to be y to the third, and 10 divided by 3 would be 10 thirds, minus, make that exponent 1 bigger, so that's y to the fourth. 12 divided by 4 would be 3. Make that exponent 1 bigger, so that's y squared. 2 divided by 2 would be 1. And we're going from 1 to 0. Plug in 1 into here, you're going to get 10 thirds. Plug 1 into here, you're going to get minus 3. Plug 1 in here, you're going to get 1. Plug 0 into each of these, you're going to get 0. So we're going to end up having just, this would be our area right here. Let's change all these into thirds. So I have 10 thirds. 3 would be the same as 9 thirds. 1 would be the same as 3 thirds. So 10 minus 9, that's 1, plus 3. Come up with an answer of 4 thirds. So that tells us that the area between these two curves is 4 thirds square units. Square units because it's area. And that's number 4 using horizontal slicing on page 380.